So let's start out with the first one up here. And we're adding those. We're going to line up the like terms. We're going to add down the columns. So 11 and negative 12 make negative 1. Negative 8x and positive 9x make positive 1x, or just plus x. And 5x squared and 3x squared make 8x squared. The next one here, we're going to do the same thing. We're going to line up the like terms. Those are the digits of the same place value. But this time we are subtracting down the columns. Negative 2 times 9. Or sorry, negative 2 minus 9. Negative 11. 13x minus a negative 8x. Positive 21x. And 2x squared minus 7x squared. Negative 5x squared. How many of you had the first two right so far? Okay. So now for the third one, we're switching over to multiplication. Remember, you had that FOIL shortcut, and if you know that and you like it, you feel free to use it. I'm going to multiply it out the long way here. 7 times negative 2 is negative 14. 7 times 5x, 35x. Now I've got 4x times negative 2 is negative 8x, and 4x times 5x is 20x squared. Now I add down the columns. I've got negative 14 there. 35 and negative 8 is a positive 27x. And then 20x squared. Any questions on that one? Number 4. Division usually looks more familiar to people if I write it like this instead of the way I have it written in the problem. This way you can see that you're going to divide each term. So 16x to the third y squared divided by 8xy squared. 16 divided by 8, 2. X to the third divided by x. X squared, good. And y squared divided by y squared goes away. So now I've got negative 32x squared y to the fourth. Negative 32 divided by 8. Negative 4. X squared divided by x. X. Y to the fourth divided by y squared. Y squared, yeah. 4 minus 2 is 2. When we're dividing, we subtract powers. 24 xy to the 6. 24 divided by 8. Positive 3 x divided by x. Nothing, it divides out. Y to the 6 divided by y squared. Y to the 4, good. So there it is. Any questions on that one? Okay, so then finally number 5. This is basically an order of operations problem. We see the parentheses, and it should always scream at us, do something here first. The first parentheses on the left here, is there anything that needs to be done inside those parentheses? No. Is there anything that needs to be done to those parentheses? Yes, times the 7x squared. 7x squared times 5x to the third 35x to the fifth. Good. 7x squared times negative 2x. Minus 14x to the third. Good. Second set of parentheses. There's nothing to do inside of them, but there is something that's going to be done to them. It's going to be multiplied by, perfect, negative 4x to the third. You got to remember the negative. So negative 4x to the third times 3x squared. Negative 12x to the fifth, and negative 4x to the third times 8. Negative 32x to the third. Are we done? What can we do? We can combine the 35x to the fifth and the negative 12x to the fifth, or subtract 12x to the fifth, however you want to look at it. Is 23x to the 10th? Say no. No. X to the fifth. When we add or subtract, we keep the same name. We were multiplying up here. That's why we combined the names. That's why we had to add the powers. When we add or subtract, we keep the same name. We can also combine the negative 14x to the third and the negative 32x to the third to get negative 46x to the third. What do you think? Doable? Anybody want to go over any more of those? Okay, there are a couple of you still working on the quiz, and that's fine. Please feel free to finish it up later. We're going to go ahead and we'll start a new material now. We've seen what happens with exponents when we raise them to a power. Now, when we had 10 to the fifth, I raised it to the power of 8. What did we do with those powers? We multiplied them. It became 10 to the 5 times 8, or 40. And it would work the same way if it was a variable in there. If that were x to the 7th to the power of 9, so it becomes x to the power of 7 times 9, which is 63. Well, what if we have 5x to the fifth, y to the third, to the power of 6? The number, the count, still has to get raised to the power. So it is still 5 to the power of 6, which is 15,625. And then we take each variable, each name separately. X to the fifth to the power of 6 is x to the well, 5 times 6, close, but 30, right? Y to the third to the power of 6. Y to the 18. 3 times 6 makes 18. So if I have 2x to the third, y to the fourth, z to the power of 9, is it going to be 18? No, it's going to be 2 to the power of 9, which is 512. X to the $27. We do 3 times 9. We multiply the powers on the variables. Y to the 36. Good. 4 times 9 is 36. We think of that as being z to the 1 or z to the 9. Very good. Something like this. There are two things happening here. The first thing that would have to happen according to our order of operations is the power. So 3 to the power of 4 is 3 times 3 times 3 times 3 is 81. X squared to the power of 4 is x to the 8. And then we have y to the 4. Good. We think of it as y to the 1, so 1 times 4 is 4. And that is still being multiplied by the x to the 3rd, y to the 5th. So 7 times 81. It's 567. X to the 3rd times x to the 8th. X to the 11th. 3 plus 8. When we're multiplying exponents, we add the powers. Y to the 9th. What if we have that? Well, it means 3x plus 7 squared means 3x plus 7 times 3x plus 7. I will catch at least one of you writing out 9x squared plus 49. It's not the right answer. We have to do the first. 3x times 3x is 9x squared. Then we've got the last. 3x times 7 is 21x. 7 times 3x is another 21x. And 7 times 7 is 49. So we combine 9x squared, 21 and another 21x is a positive 42x plus 49. Any questions on what I did there? So in your notes, try that. 5x squared minus 2. See what you come up with. So that's going to be 5x minus 2 times 5x minus 2. Five x times 5x, 25x squared. 5x times negative 2 is negative 10x. Negative 2 times 5x is another negative 10x. Negative 2 times negative 2 is a positive 4. So that will combine. We got 25x squared. Negative 10 and negative 10 makes negative 20x. And positive 4. How many of you had that?
What is this, review again?
Now we're going to the next step with powers. Well, what if we go the opposite direction? You know, we've seen that x to the 5th squared is going to become x to the 10th, right? Because they just multiply the powers. 5 times 2 makes 10. So what if I asked you for the square root of x to the 10th? Why did I put a 10 there? It should be an x to the 10th. X to the 5th squared becomes x to the 10th. I was wondering why you were looking at me funny. It becomes x to the 10th because 5 times 2 makes 10. So what if I asked for the square root of x to the 10th? Well, we know x to the 5th squared makes x to the 10th. So it has to be x to the 5th. Because that's what a square root is asking, is what number squared makes this. If you look at what happens with the powers, since we're reversing the squared, and when you square an exponent, you're multiplying the number by 2. When I square root, what has to happen to the power? Divided by 2. 10 divided by 2 makes 5. So if I have the square root of x to the 30th, what's that have to become? X to the 15. Square root of x to the 28th, y to the 12th. That has to become x to the, yeah, perfect, x to the 14, y to the 6th. The powers are divided by 2. Now, because of that, there is actually an equivalency between a root and a power. The square root of x to the 10th is the same as taking x to the 10th to the power of 1/2. A square root is the same as a power of 1/2. 10 times 1/2 is 5. That's 10 to the 5th. You can actually test that on your calculator. If you do the square root of 625, it should give you 25. Or if you do 625 to the power of 1/2, it should also give you 25 if you enter it correctly. You have to use the fraction key to enter the 1/2, or you have to put it in parentheses, 1 divided by 2, and close your parentheses. So if I have the square root of something like this. What's the square root of 64? 8. I apply the root to the number just like I did a power applies to the number. Now for the variables, I have to divide the powers by 2. So the square root of x to the 8th will be x to the 4th. Y to the 20th, square rooted, will become y to the 10th. And then the square root of z squared, z to the 1, or just z. So this is going to become, what's the square root of 25? 5. X to the 8th square rooted becomes x to the 4th. Y to the 4th will become y squared, and the square root of z to the 24th, z to the 12th. We can have this situation. There's 2 ways we can handle this. We can do the square root of 16, which is 4. Square root of x to the 5th. We make the square root of 5/2, or square root of 2.5. Or, sorry, x to the 5/2, or x to the 2.5, if you want to put it that way. Y to the 11th, same thing. Y to the 11/2, or 5.5, however you want to write it. Or the alternative way is this. Square root of 16 is 4. X to the 5th, when we square root it, 5 divided by 2 is 2, with a remainder of 1. So the remainder stays inside the radical inside the root. Y to the 11th, when I square root it, 11 divided by 2 is 5, with also a remainder of 1. So either way of writing that is acceptable. When I do a test or a quiz, I'll try to be more kind to you than that. What's that symbol mean? Cube root. So it means we're looking for the number to the 3rd power that equals that. So if that were x to the 12th, what to the power of 3 equals x to the 12th? Well, x to the 4th to the 3rd power. 4 times 3 make 12. So this has to be x to the 4th. Looking at that, can you take a guess at what happens to the powers when you do a cube root? Divide by 3, or 1/3. In fact, on your calculator, if you can't find the cube root button, you just take x to the 12th, the power of 1/3 will do the same thing. So if I have a cube root of 27, x to the 21st, y to the 9th. What is the cube root of 27? 3. 3 to the 3rd power is 27. Remember, the number you actually have to do the root. You don't just divide on the number. Then for the variables, you do just divide the powers. X to the 21, third root would be 7. And the third root of y to the 9th, 3. In the big book, page 345, it is exercise 13.6. And page 349, exercise 13.7. In the little book, here's 26 and 27.